Hello and hi students, this is Dr. Sarkar over here. Welcome to Source Classes, and today we are going to discuss another oxidation reaction which is called Corey-Kim oxidation reaction. Again, very much useful for converting 1,2-diols to the ketones or aldehydes. One more important point, there is no cleavage of the CC bond over here as we had learned in the Malapride reaction. So out here, let's see what is the reagent. Formation of aldehydes and ketones from alcohols makes use of the complexes from the methyl sulfide, which is the dimethyl sulfide, with chlorine or using N-chlorosuccinimide, also known as the Corey-Kim oxidation process. Out here, the dimethyl sulfide, the salt is generated and reacts with the alcohol, as we can see over here, to lead to the formation of the alkoxysulfonium salts. Okay, so these are the alkoxysulfonium salts. This is your NCS and this is your dimethyl sulfide. Okay, the reaction was found particularly applicable for the oxidation of 1,2-diols in which one alcohol is tertiary to give alpha hydroxyaldehydes or ketones without the rupture of the CC bond. So this is the most important part about this reaction. So out here we have been given either a 1 degree or 2 degree alcohol, and we can see 1 degree alcohol selectively oxidized to aldehydes, whereas 2 degree alcohols are oxidized to ketones. Mechanism: NCS will be undergoing nucleophilic attack from the dimethyl sulfide, and out here it will be grabbing the chlorine. The NCl bond will break up. Then further the nucleophilic attack on sulfur takes place, leading to the formation of the Corey-Kim reagent. And since the sulfur is having plus charge over here and it is having the d orbitals, so it can be nucleophily attacked by the OH group of the alcohol. The minus charge on the succinimide of which is on the N obviously, will be making a basic attack on the hydrogen and will be abstracting the proton, leading to the formation of the succinimide, and further the triethylamine used in the reagent, okay, which is much more basic in nature, will be abstracting the hydrogen, which is more or less acidic in nature, from the alkyl sulfonium salt. And since the alcohol we used over here is obviously 2 degree, so the product formed over here is going to be the ketone. Let's have a look at the practice problems. Out here we have been given this particular alcohol, so obviously using this reagent over here, that is a Corey-Kim oxidizing agent, we will be leading to the formation of what? This type of a ketone over here, because it is 2 degree alcohol. Further, a double bond is formed over here, which can be further removed by the zinc acetic acid. Okay, and our product obtained over here is going to be this. Next, as we had discussed, this is a 3 degree alcohol and this is a 1 degree alcohol. So using a Corey-Kim reagent, one can oxidize the primary alcohol selectively, convert it to the aldehyde, and that will lead to the formation of a alpha hydroxyaldehyde. Few more practice problems. As we can see over here, this particular OH is sterically hindered and this is a little free. This is 2 degree, that is also 2 degree, so it will lead to the formation of ketone over here, leaving this one out. Next, we can see we have only one OH group over here. The stereochemistry of this is not defined. However, when you use the Corey-Kim reagent, obviously oxidation will take place over here, and so a ketone is formed. In the next one, we can see there are two OH groups over here. Alright, and both are secondary, So using the Korrekim reagent, we can say that oxidation of these two OH groups will take place, leading to the formation of the 1,2 ketones. Okay, so that is all about the Korrekim reagent. Keep visiting our classes. This is Dr. Sarkar saying goodbye. Have a great day.